Welcome back, Math Marvel. In the last lesson, we talked a lot about congruent figures. Today, we're going to talk about similar figures and use some 7th grade math and some 7th grade strategy to recognize and prove mathematically that two figures are similar to one another. So let's look at this first example. Which rectangle is similar to rectangle A? And again, similar means my angles are going to be the same, but my sides will be proportional. So you're going to look for sides are proportional to one another. So we're going to use math the same way that we did with rates and proportions from 7th grade. And we're going to see once we put in the numbers, if the cross products are equal to each other, if they're congruent, then we know that they are similar to one another. If we do cross products and they are not congruent, then they are not similar to one another. So let's look at this one here. What we're going to do is we're going to look at the ratio of the smaller side to the larger side. And we're going to look at for rectangle A and B, and then we're going to look at rectangles A and C. So let's look at for A to B. My smaller side measurement is 3, my larger side is 6. For B, my smaller side is 2, my larger side is 6. And just like in 7th grade, remember, we use our labels here on the side to know where we're putting things in. And this will tell us a little bit more about how we're organizing our numbers. Now, looking at these two ratios, and they're you can think of them as fractions if you'd like, would you say that 3/6 is proportional to 2/6? Would you say that is true? So think to yourself. So now let's prove it mathematically. We're going to use cross products to do so. So all you would do is you would just multiply. So 6 times 2 is 12. 3 times 6 is 18. These two numbers are not equal to each other, so these would not be proportional. And this makes sense, right? Because as a fraction, 3/6 would not be equivalent to 2/6. So I know that this would not work. Let's try with A to C and see if these two rectangles are similar. And again, to be similar, they have to be proportional. So here's my first ratio, 3/6. So I'm going small side to large side, and 2/4. So would you say that those two ratios are proportional? Well, if you were talking just fractions, yeah, 3/6 is equivalent to 2/4. So I know they are proportional, and I can prove it mathematically using my cross products. 6 times 2 is 12, and 3 times 4 is also 12. So yes, these two do work. They are equivalent to one another. Those fractions would be equivalent. Those ratios would be proportional to each other. So we can say that rectangle A is similar to rectangle C. That would be our truth. So let's write down that full sentence so we have it. Rectangle A is similar to rectangle C. Hit pause so you can jot this down in your notes. And let's do one more. Now these are simple numbers. So just by looking at them, you can probably tell, Sarah, why do we have to do cross products? Well, you're not always going to have as friendly numbers and ratios. So let's look at this second example here. And again, we still have friendlier numbers. However, we have now an unknown. We can still use math to do this. We want to know, we already know they are similar, so we can use that to find the missing side. I'm going to do the same type of figure. I'm going to do small to large. And in this case, yes, I'm going to use 6 and 9 as my, actually, no. I know 6 corresponds with 9. Those are both the smaller ones. And here, 8 is the larger side with the measurement I have, and it corresponds to X. All right, now I'm going to use my cross products. And again, you may not have done this in 7th grade, and if you're new to math mini lessons, you've never done this before. So watch what I'm going to do. I'm going to just start with my cross products. 8 times 9 is 72. And 6 times x is just 6x. So this is what I have. 6x is equal to 72. Now I can use my algebra to isolate that x. 6 times the number equals 72, so I'm going to divide both sides by 6. And x is equal to 12. So that now I know the value of that side. Okay, and I want to make sure I have the full measurement there. So I'm going to stop there, Math Marbles. So as you can see, all I did was identify the corresponding sides first. That was my first clue, which sides really correspond in my figures, and I'm using my notations for that. Now I'm using math to actually set this up. The small I used as the 1 dash, my large were the 2 dashes. And once I put in my values, I can cross multiply to get an equation, which I did. 6x equals 72. And then I'm just using my algebra skills to find the missing number by isolating the variable. That's all I did. So you might need more practice with this, especially if this is your first time with this structure. But if you've been with us since 6th and 7th grade, then you're very used to it. But we're going to stop there, Math Marvel, so you can get some practice. You're going to do the same thing in today's lesson. See if you can identify which figures are similar to one another using math, or use the structure of math to find the missing side of 2 similar figures. That's it for today, Math Marvels. We will see you in the next lesson. Take care.